Hi, if we want to talk about generalized coordinate system, first we have to memorize some kind of coordinate system that we are familiar with. That is Cartesian coordinate system, cylindrical coordinate system, spherical coordinate system. This is three types of coordinate system we are familiar with. Here we have plot cylindrical coordinate system, Cartesian coordinate system and spherical coordinate system. Let's consider a particle P is existing in the Cartesian coordinate system and the component of the Cartesian coordinate system is x, y, z. To specify particle position in cylindrical coordinate system, we can represent that position of the particle with r, theta and z. Here z is the length of the cylinder. For spherical coordinate system, a particle's position can be represented with phi, theta and phi. In this three coordinate system, we can specify the position of a particle like this. But to being specific about generalized coordinate system, we can say after analyzing a phenomenon in a generalized coordinate system, it is possible to transform that phenomenon into any other coordinate system. If we consider a Cartesian system containing two particles, one of them is P1 and P2. Let's consider P1 particle with component x1, y1 and z1 and P2 particle is specified with component x2, y2 and z2. We can represent these two free particles with the set of number x1, y1, z1, x2, y2 and z2. And if we consider that Cartesian coordinate system is containing n number of particles, then we can represent that n number of particle system by the number of set x1, y1, z1, x2, y2 dot zen like this. If we include time, then we can write x1, y1, z1, x2, y2 dot zn and t. Here this set of number is representing n number of particle system in Cartesian coordinate system. Here we have plot a generalized coordinate system like this figure. Let's consider this generalized coordinate system is containing a particle which is denoted by P and the components of this particle in the generalized coordinate system can be denoted as Q1, Q2 and Q3. Now let us consider two free particles are existing in two coordinate system at the same time. One of them is Cartesian coordinate system and one of them are generalized coordinate system. Let's consider position of the particle P1 along Cartesian coordinate system is x1, y1, z1 and position of the particle P2 with the component is x2, y2 and z2. Here P1 and P2 particle system can be represented by using the set of number like x1, y1, z1, x2, y2, z2. This number of set is the position of the two particle system shown in figure. Now we can say this two particle system is also existing in generalized coordinate system. Along generalized coordinate system, we can say the coordinate of the particle system, we can say that is q1, q2 and q3. Now if we consider this two particle system is p, then position of that p along generalized coordinate system can be denoted by the set of number q1, q2 and q3. Here each components of generalized coordinate system is the function of Cartesian system. So we can say that q1 is equals to function of x1, y1, z1, x2, y2, z2. If we apply time here, we can write that q1 is equals to q1 of x1, y1, z1, x2, y2 and z2 and t. This is the our q1 component of generalized coordinate system. So we can write that q1 is equal to q1 of x1, y1, z1, x2, y2, z2 and t. Let's consider our particle system is containing n number of particles. Then we can say our q1 component can be written like x1, y1, z1, x2, y2 dot zn and t. This will be the one of the components of generalized coordinate system. Then other components of the generalized coordinate system can be written like q2 is equals to q2 x1, y1, z1, x2, y2, zn into t here. And if we consider that our generalized coordinate system is containing I number of dimension, that q1, q2, q3, qi, let's say q4. If we consider our generalized coordinate system is containing I number of dimension, then we can say our ith dimension of generalized coordinate system can be written like qi is equals to qi x1, y1, z1, x2, y2, zn and t. These will be the components of generalized coordinate system. Now by doing transformation, components of Cartesian coordinate system x1 is equals to x1, q1, q2, q3 dot dot, let's say this will be q3n and t. This is the one of the component of Cartesian coordinate system. We have transformed it from the component of generalized coordinate system. Now we can write x2 is equals to x2, q1, q2, q3 dot dot q3n comma t. Here q3n is representing that our n number of particle system, that each of the particle is containing 3 components. That means our generalized coordinate system has only 3 components, and that is q1, q2 and q3. For a particle we will get 3 components. That's why this n number of particle will be containing 3n number of components and with t. Now we can write that our ith number of our I number of component for Cartesian coordinate system will be q1, q2, q3 dot dot q3n and t. Here this is the transformed Cartesian coordinate system from generalized coordinate system.